A very good morning to all. Moving on to today's topic. So you all know what is a magnet. So what is a magnet? It is a piece of metal with strong attraction to another metal object. So we can say magnet is an object that attracts other objects that are made of iron, nickel, cobalt, etc. So now first let's discuss about, can a magnet attract a magnetic object without being in contact with it? So is that possible? Yes. So magnetic forces are non-contact forces. They push or pull objects without touching it. A magnet does not have to be in close contact with the magnetic material to attract it. The magnetic force can be exerted from a distance. So that is, as the distance increases, the magnetic force is reduced. So the magnetic force can pass through non-magnetic materials like paper, plastic or wood. So non-magnetic materials means materials which have no magnetic properties. So magnetic force, it can pass through the non-magnetic materials like plastic, wood, paper, etc. The next is, are all magnets of the same strength? So here you can do an activity to find out whether all magnets are of the same strength. You can take 4 different magnets of different sizes and you can take some paper clips. So using each magnet, find out the number of paper clips attracted to the magnet. So do all the magnets pick up the same number of paper clips? No. So a small magnet may attract more number of paper clips than a large magnet. So we can say that the size of the magnet does not indicate its strength. The next is about temporary magnet. So what is a temporary magnet? A magnet that remains magnetized for only a small time interval as compared to a permanent magnet. That is called a temporary magnet. So let me tell you once again, a magnet that remains magnetized for only a small time interval as compared to a permanent magnet. So that is called as the temporary magnet. For example, if a piece of iron, when it is brought near a permanent magnet and it is allowed to remain in contact with the magnet, then this piece of iron, it becomes a magnet for some time. Then that piece of iron, we can call it as a temporary magnet. So that is when a magnet that remains magnetized for a small period of time. Then we call it as the temporary magnet. So when a piece of magnetic material like iron, when it is converted into a magnet, then we can say that the iron piece is magnetized. Okay, so when this piece of iron, when it is converted into magnet, we can say the iron piece is magnetized. So when do we say a needle is magnetized? When you take a magnet and rub the magnet against the needle for at least 5 times, we can say the needle is magnetized. So that is, if a magnet is struck on an iron needle only in one direction, we can say the needle is magnetized. And that method is known as the touch and stroke method. The next is, why does an ordinary iron needle become a temporary magnet? So here you can see a random arrangement of molecules in non-magnetized piece of iron, and there you can see arrangement of molecules in a magnetized piece of iron. So we know that iron piece is made up of iron molecules, and in a magnet each of these molecules behaves like a magnet. So each of these iron piece, it behaves like a magnet, and therefore it remains in the north-south direction. And what about a non-magnetized iron needle? So here the molecules are arranged in a random manner. So when we stroke a magnet on a needle only in one direction, what happens? The molecules get magnetized, right? And they behave in a particular manner, and the iron needle behaves like a magnet. So by stroking a magnet on the needle only in one direction, the molecule gets magnetized and the needle behaves like a magnet. So I hope it is clear to you. You can go through page number 179 and 180 and read what we have discussed today. We'll meet in the next class and we'll discuss the last portion of this chapter. Till then, thank you.